Huh?
Do you just get like, how do they?
You get like a percentage of the proceeds. I didn't know how it all worked. I had to ask Coach Stacy. But it's like if you bring in, like if people who say your name, because they have to come in and be like, hey, I'm here for the Heritage Missions. But then if you bring in $200 or more, no, at least $200, you get 15%. If you bring in at least $500, you get 20% of the sales. Yeah, which is actually pretty fun. So, and if we can get a lot of people, we'll get the 500. Huh?
That's really good.
Yeah, like the percentages.
I mean, and Chick-fil-A's
And
expensive
Chick-fil-A's,
too, so.
yeah. But Chick-fil-A also, like, they care about the community. Like, it was so easy to get, well, we've alumni that work there too and stuff like that. But, yeah, it was so easy, so that was cool. We did not get to finish this yesterday, right? But what were we doing? Why is there an integral up here?
I don't know. We were doing something about falling. Oh, thrown upwards. Okay.
A ball is being thrown and it's coming down, so then the negative 32 came from
Find
gravity. Good. Negative 32 came from gravity. What else? They're saying find position.
Yeah.
The integral of acceleration gets me
Velocity.
why? Why does it get me velocity?
Because
Who is
the area.
acceleration? Good. And doesn't an integral go backwards? Does that make sense? So the integral goes backwards, so if acceleration is put in, that's v prime, I'm going to get v out. Okay, so acceleration is v prime, so if I integrate v prime, then I will get to velocity. So guys, I plugged in acceleration, it was constant. We're totally disregarding any sort of friction or anything like that. Or any sort of wind, we're totally disregarding all of that. And we're just saying, hey, take gravity, negative 32, how do we integrate it?
And the C.
It's a constant, so it's going to be negative 32x. No. What's my variable? T. And then plus C. Now hold on, is there anything in this problem that would help me solve for the C? Any sort of clue? Yes, there is. What is it?
The initial velocity.
Good, initial velocity. So initial velocity, when time is 0, I put the point up here. When time is 0, v is 64. So can't I plug in 0, 64?
Yeah.
Cool. And when we do that, can you guys see what's going to happen?
64 equals C.
Yeah. 64 equals 0 plus c, so therefore c equals 64. Do I know what velocity function is? Yeah. V is equal to negative 32t plus 64. Now, is this what I'm trying to find for letter A?
No.
Bummer. Well, that's okay. Because velocity is related to position how?
By deriving
It's the derivative of position. So couldn't I say, if I wanted to find position, I'm going to call x of t or s of t. Couldn't I take the integral of its derivative? Didn't we just say that's the same thing as velocity? To find position, I could take the integral of its derivative. That would go back. And who is its derivative? Well, velocity. So we plug in the velocity function, take the integral, and side derive. So kiddos, use your skills. What's the integral of negative 32t? Careful, not derivative, integral. So dt squared
Negative 16.
over 2, which would negative 32 over 2 is negative 16. Does that make sense? And then 64 is a constant, so that'd be 64t by 64x. And then what we do then? Plus c. Now, do we have a way to find that plus c? Yeah. In the beginning, it tells us initial height. So initial height, when t is 0 at the beginning, initial h or x or s or whatever you want to call them, the position is 80. So can't I plug in 80 and 0?
Yes.
Good. Do you see what's going to happen? C equals 80. But depending on the complexity of the function, that might not always happen. The initial might not always be C. But very frequently it will be. But if you had another clue, when you knew or if you knew what the position was after 1 second or 2 seconds or 3 seconds, you couldn't just say 0, 0, C equals. But if you know the initial, C is going to equal that initial height, and you plug and chug, and that's the answer to A, right?
Yeah.
Find the position function. Okay, cool. X of T is equal to negative T squared. Sorry, negative 16 squared plus 64T plus 80. That's our final answer, right? Now, this does. Huh?
They give us a constant there, so we just pretty much.
And when you integrate, there's always a plus C. So we just had to go back to the problem and find the clue to find. If they hadn't given us an initial height or any sort of height at a time, we would have been stuck with the plus C. There is a formula for physics. Given a constant acceleration in a free fall model, if you're given a constant acceleration, which they would normally symbolize what, A sub naught?
What?
They would say that position is equal to 1/2 A sub naught T squared plus V sub naught plus X sub naught. 1/2 constant acceleration times squared plus initial velocity times time plus initial position. Is that what ended up happening in our equation?
I mean,
1/2 of gravity was negative 16, initial velocity was 64, and initial position was 80. Physics people just have a formula and say, hey, let's memorize it. And they can also say from that velocity is equal to A sub naught T plus V sub naught, which is what we had right here. Our gravity times time plus initial velocity. And then they would say that their acceleration is equal to that constant number. So these are formulas from physics in some way, shape, or form. But physics people get this big old huge page of many, many, many more complicated formulas than this. But they would just memorize this. But we can say, wait, given a constant acceleration, no big deal. Integrate, and then you get velocity. Integrate again, and then you get position. So are these good formulas? Yes. Could they shortcut things a little bit in homework a couple times? Yeah, they could. But could you also just use the idea of calculus, realizing on an AP exam they're not going to require you to have these memorized, and they might actually give you different accelerations where the velocity must be integrated and it'll equal a different answer. They don't have to give you a constant acceleration, they give you something else. It's important for us to understand the idea of, given a second derivative, we can go backwards twice, like you guys did in number 44 of homework that we created yesterday. Given a second derivative, we can go back twice, no big deal. If they give us 2 clues, we can plug in both of those clues and find the plus C's. So physics says, hey, there's some formulas for this one case. Calculus says, hey, we can do it no matter what the acceleration is, as long as you can state it as a formula.
Assuming that you're not using calculus when doing physics, yeah.
we didn't do B.
Oh, we didn't do B. Oh, what did B say?
When does it hit the ground?
Oh, when does it hit the ground? You guys know that clue?
Velocity is 0, right?
Hit the, ooh, something is 0. Hit the ground. What's 0?
Position equals negative
Position.
80 or 0.
Remember, things go splat.
Just use
They
negative
hit
80.
with the speed if they hit with the velocity.
Oh, okay.
After it's on the ground, now its velocity is 0. But the velocity when something's going down is going to be speeding up, and all of a sudden, velocity. It's a velocity around. It's going to be 0. But objects hit with a velocity. That's why, ow, I just sprung just a little bit, not much. Okay, so we have to set position equal to 0. And didn't we put that on a forever card so you would remember?
Yeah.
Why am I pulling out a negative 16 from everybody?
That goes into B.
Everything a little bit easier, right? 80 divided by 16 is 5. So we go ahead and factor. Can we divide both sides by negative 16? Not that you have to show it, but just understanding where it goes. So all we're worried about is the polynomial expression 0 equals. You guys factor here? Yeah, minus 5 plus 1. That makes sense. Factors of negative 5, that had to be negative 4.
Oh, I haven't done that.
Negative 5 and 1, yeah, that's the one. So then t equals, remember? Factors equal to 0, set each equal to 0, we end up with t equals 5 and -1. Which one makes sense? Only the positive sign. Because if the ball is thrown upward, -1, the guy's still holding the ball. It's not even that. Yeah. So we could say 5 seconds. The domain of this problem would be 0 to 5 seconds because after 5 seconds it's on the ground. It's not like continuing the parabolic motion. And before 0 it wasn't thrown yet, so it didn't even have any sort of motion yet. Okay, thank you. Woo, we got through. Letter B. How about this guy? I'll give you a second to read. They tell us basically use gravity as the acceleration, as the constant acceleration for this model.
That's generally what you do.
For free fall.
Oh my, it's gonna take long. Not to say neglect and resistance.
It's technically in the book. Alright. I'll be all technical.
Well, I mean, should I take it into account or?
No.
I don't know.
Dude, it sounds better. Ba-da-dum. That just means for the physics people, aka Tyler, that he doesn't have to stress about thinking about air resistance. Kiddos, what are the 3 big concepts? Ooh, hey, motion packet. Motion packet, front page. What's the very first question? And it's not number 1, look above it. There's like a paragraph and some space. What's the very first one say?
The 3
3 closely related concepts. 3 of them. What are the 3? Position, velocity, acceleration. Write it down in your motion packet. Position, velocity, acceleration. Last semester, we had to start with position to find velocity. Have velocity to find acceleration. We could only derive. We could only go one direction. So in your motion packet, position, velocity, acceleration, to go down, you take derivatives. But in this one, we have an acceleration, so we're going to go backwards. And to go backwards from acceleration to velocity to position, what are we going to have to use? Integration. Good. The differentiation goes down from position all the way to acceleration. Integration goes back up. So this one, if I have A, how do I find B? How do I find X? And why am I saying that? Well, guys, isn't that a position? Yeah. If you want, I guess you could name this H of T instead of X of T. That's okay, no big deal. I know what to make H. I know to make H 555, but the problem is I have no equation yet, unless I memorize that physics one. Because this one is a constant acceleration. Let's make sure we know the math. To get to velocity, how do we find it? Integrate. Good. We're just practicing integrating. What's the integral of -32? -32t plus c. Good. So hold on, pause. Do we know the initial velocity?
No, there's one condition.
No. But we could make it if we wanted to. We could make it a nice little V sub naught, which indicates V of 0. So we could go ahead and with this plus C, we could say, oh, hey, wait, that plus C is going to end up being the initial velocity. When t is 0, what is velocity? So if you want, you could make that nice little variable. Or you could just leave it a plus C, because in the next step to get to position, which we do know a clue about, the 555, we're going to have to integrate again, right? Okay. So to integrate again, we have the negative, that's going to be a t squared. So negative 32 over 2, and 16. Then I have my v sub naught t, and I'm going to have my x sub naught. Ooh, sorry. I went to physics equal me. Plus e. Well, let's say that.
What do you do?
But plus c is going to be the initial height. When time is 0, the height is going to be the plus c. So hold on. 555 isn't where it starts though. If it was being dropped from the top of the Washington Monument, then the c would be 555. Where is it being thrown from? So where are we going to make our initial position? We're going to make it 0. And say when time is 0, position has to be 0, so that c has to be 0. So ground level, that was another clue that's kind of hidden. That one said initial position was 0. That's why we said c equal to 0. We'll struggle then. How do we, if c's gone, what can we do here? We don't know him. How do we solve? Question, do you have to make it past the Washington Monument?
No.
No, you just have to make it to the Washington Monument, right? So, think about it this way. Here's the Washington Monument. Isn't it kind of pointy? Washington Monument. If you're trying to make it to him and you're throwing it up, question. Couldn't you say it's the highest you're going to make it? So then, what's the horizontal tangent line at that point? Velocity. If all you're doing is making it to the top and you're not making it go beyond, you're like, I'm going to be doing good just to get it up there. All right, fine. So if we can make it actually to the top, then what's the velocity going to be at the very peak of the motion? So now we can say 0 is equal to negative 32t plus v sub naught when 555 is the height. Now let's use our math skills to say, how do we solve a system of equations with 2 unknowns and 2 equations?
Substitution.
Substitution is a great one.
Or
Substitution. Who do we want to get at the very end?
V sub
V sub naught. But they want to say how fast you should throw the ball. So let's go ahead and leave v sub naught in. Let's solve for t to get rid of the t in the next equation. So then I'm going to, what, subtract v sub naught?
V sub naught over 32.
Yeah. You guys see what I did? Subtract the v sub naught, divide by negative 32. And once you have that expression, where are we going to plug it in?
It's a bit wonky, but I guess it works out a bit. Not very annoying.
It'll work out. It's a little nasty, but that's alright. 555 equals negative 16 times v sub naught over 32 squared plus v sub naught times v sub naught over 32. Gnarly, right? Use our calculator. How can we use our calculator? We can make these X, we can make these M, right?
This is going to be a bit weird, but could you do,
You could do quadratic formula.
or no, could you cancel out because that's, isn't it 16 squared times 2 squared?
Yeah,
So you could cancel out
one of the
16.
16s. So you would have 4 times 32. What Tyler's saying is that this down here would be v sub naught squared all over 32 squared, which is the same thing as 2 squared and 16 squared. It's 32 squared is 2 times 16 both squared. And that's pretty nifty because then we can cancel out one of the 16s. Isn't it a lot easier just to be like, hey, 4 times 16 is 64? And this one you'd have v sub naught squared all over 32.
Wait, for the first piece of time, is it squared?
Yeah, this is squared. I don't know why I put 0. That was awkward.
Especially if this is a non-calculator. But
Yeah, if there's a non-calculator, you have to do whatever you could, and that would be one way of doing it. Wow, that was right there. You could multiply both sides by, because that's going to be 64. You can multiply both sides by 64. That's just going to be a bit of a struggle, but it would make everything nice and pretty. If you multiply this side by 64, and that side by 64, you would end up with
do some
negative v sub naught squared plus 1 and 2, 2 v sub naught squared
It's actually not that awful because
It's not that awful, you just have to do a big old
yeah, you can do the
multiplication.
multiplication off to the
Wait,
side, but
where's 64 when you do it on the other side?
Because over here it reduces to be 1 and 2. And then this one, that is 64, so it just cancels.
Oh, okay.
So then negative. And then we can just add that to be a base and not squared. So all you do is take the square root of this thing, which is not a nice number, because that square rooted is 8, and that square rooted is not 35. So go team. So what I need is the positive, because we don't want the negative, because it's being thrown upward, I need a positive velocity to propel it up. Because the square root is 64 times 555. Alright, fine. Now use your calculator. Tyler, what do we got?
what? Oh, I'm doing the motion.
That's okay. Throw it in real quick. Square root of 64 times 555. You have your calculator in hand.
64 times 5. 188.468.
And that, I think, is feet per second squared.
Uh,
No. Velocity. Sorry. Feet per second. Acceleration is feet per second squared. Because remember, velocity is the derivative of position with respect to time. Feet per second. Remember related rates and how we did units? Feet per second. Hey, baseball player might be able to do that, yeah?
Boy.
Don't some baseball players have like a 200 mile per hour? Oh, mile per hour. Feet per second is a little bit different. Struggle. Dimensional analysis, build bridges, and let's see if they could do it. Just not right now. Okay.
People like pitch 200.
What?
People
Just
pitch
100,
200.
like,
I've heard 100, but
Yeah,
I've never
100.
heard 200.
Oh no? No one does? I thought there was like
I
I thought there was like a small club of like 1 or 2 here and
I've
there
heard
that's done it.
God or something.
100 is like the highest?
I'm
the
pretty
highest,
sure.
but
It's not high,
highest
but
like 120.
one highest
Oh.
people.
Struggle. I thought that they was higher than that.
Okay.
Okay. Well, that's not very exciting. I mean, it is, but I don't think they're gonna make it.
Yeah, would it cricket do
Cricket
that?
may go fast.
Huh?
Cricket would probably be faster because the ball's smaller.
Small.
I actually don't know anything
Oh,
about
that
cricket.
could be a different speed.
I don't know, that's weird.
All I know is
That is
cricket,
good.
it's like
Football will be slower though because it's a bigger ball. It's not really anything smaller than ping pong. No, it's lighter though. Anyway, how about this one? I think it's our last like book example, guys. We haven't really gotten into the packet, but that's okay. Tuesday is actually going to be like a work day on 4.1b, which is going to probably be mostly us finishing the motion packet. So probably what I'll do is just take this off. The book work is due Tuesday. Sound good? And motion packet we'll play with on Tuesday. Wednesday we'll go on to section 4.2. Sound good? And that's also partially for choir people in periods 1 and 6, and ASB people who need to like catch up with integration quizzes and stuff. They can do it on Tuesday. So you guys will be working on the packet on Tuesday. Cool? Okay. Let's work on this last example, I think, for book work. You guys see that now we're dealing with meters? Ooh, initial velocity. Find the velocity. So how do we do that? They'll give us a velocity function. Make one. Exactly. No stress. If they give us a rate of a rate, go back to just the rate. That's kind of confusing. If they give us acceleration, go back to velocity. What's the integral of negative 9.8? Negative 9.8 c plus c, and who is going to be the c if, sorry, that's not acceleration equals. That's velocity equals. Who's going to be the plus c? When t is 0, c is going to be the basic. Now we could, of course, put the plus c, we could plug in when t is 0, v is 33. But as you guys have been seeing, that ends up just giving us the c. But yes, once again, we are plugging in technically the point for velocity when t is 0, v is 33. And that's how we can plug in that plus c. I'm just using a little bit of physics notation.
How do you know if it doesn't, when it wouldn't end up being this? If it's always initial velocity, is it always going to be like that? That c is that.
Normally. But remember I said there were these more complicated differential equations, like when you have two sides integrating and this side's harder than just, hey, it's y. The c's gonna get like caught in like a square root or an e to the power of or an ln. And when it's caught in, then you're gonna have to make sure to plug in 0 and then see how to make that c rectified situation. But in this one, the nice thing is you can always double check, put initial, t is 0, 33, oh yeah, 33 is c. So wait, what are they asking for? Find the velocity at? Oh, all we have to do is plug it in, v of 3, and v of 5, that was easy. Seconds, the units match, no building bridges, we're good to go. So, negative 9.8 times 3 plus 33, negative 9.8 times 5 plus 33,
31 is
4 and 2, 29.4, which would be 3.6? Someone double check this. I think that's right. There's 5 times, that's 45, and then 4 would be 49, negative 49 plus 33 would be 16, negative 16. Yeah, 86. How about letter B? How high will it rise? Height. Position. Ah, do I have position yet? No, but how do I get to position? Go find it. Plug velocity into an integral, right? Now, we know for the t term we're going to have t squared, but aren't we also going to have it divided by 2?
Yeah.
What's negative 9.8 divided by 2? 4.9.
Oh.
Think, cut 9 in half, that's 4, but you have a leftover 1, cut 18 in half, that's 9. Oh. Then I have 33t plus c, which is going to be the same thing as if t is 0, the initial position. What's the initial position?
As long as it's from the ground.
Ground left 0. So when t is 0, height is 0. So then, what's going to be 0? So we get a 4.9 t squared plus 33t. That's my position function. Do we finish it?
How high will it rise?
Ooh. What am I going to do for how high will it rise?
Oh, you find the
Velocity is 0, like the top of our Washington
It'll
Monument.
give you a T plus it.
Find t, plug into x. Guys, hold me at 10, 4.1b. Bring it Tuesday with your motion packet.
Okay.
I will explain the motion while we try to plug. Oh! Play with the bookwork. If you want to play with the motion packet, you can, but that'll be our day Tuesday. Bye, guys.
Or not the calculus play.
But are they looking for the distance or the displacement?
Total distance.
So
So you do have to do absolute value of the changes in between the stopping